Hi, here I am with another presentation based on Haloalkanes and Haloarenes chapter for class 12th from organic chemistry. And as you can see, I'll be discussing here the reasoning questions, which is a very important part of organic chemistry. So I have selected a few questions. One by one, I'm going to discuss them. The first question is the CX bond, the carbon halogen bond enthalpies for haloalkanes follow the given order. As you can see here, the order which is given is CF strongest, then CCl, then CBr, and the weakest bond is CI, so we need to explain. Now it is very clear that if you see them, there is difference in the halogen part only. Carbon is attached to different halogens. So depending upon the size of halogen, we'll answer it like this, that as we go down, fluorine, chlorine, bromine, iodine, the size of halogen is increasing. And because of that, the strength of the bond with carbon decreases, and this is how you express your answer. I have included standard answers here so that when it comes to expressing your answers, you don't get confused. You know the reason. Now, how to put it nicely in words, that is here in front of you. So, you will write as we go down, the size of the halogen atom increases, fluorine being the smallest, iodine being the largest, hence the strength of carbon halogen bond decreases from top to bottom like this. Generally, the reasoning questions are asked for 1 mark. So, you should not write too much detail. You have to be very specific in your answer. It's very rare that they ask you for 2 or 3 marks. It happens in some of the questions that more reasoning, more points are required. So, they may ask you for 2 or 3, but generally we get a 3-marker question for reasoning, and each part, there are 3 parts, each part is for 1 mark. Okay, the next question is why thionyl chloride is preferred to convert alcohols to alkyl halide. Thionyl chloride is SOCl2. So in the preparation of alkyl halides from alcohol, the first preparation given in NCERT, there are so many reagents given. Out of them, this thionyl chloride is considered the best. The reason is, when you write down the reaction, there are 2 gases being produced. Alcohol on reaction with thionyl chloride produces the required alkyl halide and 2 gases, SO2 and HCl. Now these 2 gases are escapable. So you get a pure alkyl halide, that is why this is preferred. Simple answer. Next is the reactions of primary and secondary alcohols with HCl require the presence of a catalyst, zinc chloride. With tertiary alcohols, the reaction is conducted by simply shaking the alcohol with concentrated HCl at room temperature. So, the reason for this is that when any alcohol reacts with HCl, the carbon oxygen bond is going to break and you get RCl by breaking of this. Now it depends that what is the nature of this carbocation that we are getting by this breaking of the bond. So here the answer is the carbocation which is formed. If it is tertiary carbocation, it is the most stable, it will be formed quickly. So you just need to simply shake the alcohol with concentrated HCl. There is no need of catalyst. Then secondary carbocation is less stable than tertiary and primary the least stable. That's why they need the catalyst to carry out the reaction. So basically, it depends upon the stability of the corresponding carbocation. Now, the next question is the methods of preparation of alkyl halides from alcohols, that is by reacting with halogen acid HCl with the phosphorus halides PCl3, PCl5 and thionyl chloride. These are not applicable to prepare haloarenes. So we have to give the reason. The question is, if you have alcohol and you reacted with say PCl3, for example, you get RCl and the byproducts. But the same reaction cannot be used to carry out the preparation of this haloarene? That's the question. So the reason for this is that if I have to prepare haloarene from phenol, it is difficult to break this carbon oxygen bond because of resonance. There is partial double bond character. But in case of alcohol, there is no such problem. So this bond can easily break and easy substitution takes place. That's the reason for this. Next question, a very important one. Haloalkanes react with KCN to form alkyl cyanide, that is RCN, while with AgCN, the main product is isocyanide, that is RNC. So the reason for this is when haloalkanes react with RX haloalkanes, when they react with KCN, potassium cyanide being more ionic in nature, it easily breaks this bond. And the carbon, because we know that cyanide is ambident nucleophile, it can make bond through carbon or through nitrogen. Both are available. In this case, because the carbon and potassium bond is breaking quickly because of more ionic nature of the compound, predominantly ionic we write it, it provides cyanide ion in the solution and you easily get RCN. But what happens in case of AgCN? When you react this with AgCN is not that ionic in nature and it does not provide cyanide ion easily. By that time, the nitrogen, since it's ambident nucleophile, it offers its electrons to R plus and isocyanide formation takes place quickly. That's the reason. Isocyanide is the main product in that case. Next question. Addition of bromine and carbon tetrachloride to an alkene results in discharge of reddish brown color of bromine. This is a simple test of unsaturation also, that if you have a double bond alkene, generally we write like this, and it reacts with bromine, then bromine has that reddish brown color. Here addition reaction takes place and it produces a dibromide. Dibromide means on both the carbons one Br will come and you get dibromide. So now since bromine is not existing, Br2, it has reacted, that's why the color is no more visible. And these halides where the halogen atoms are on adjacent carbons, they are called vicinal dihalides. Wick dihalide or vicinal dihalide. So this is the reason that formation of this dihalide results in. The next question is why Finkelstein reaction is carried out in the presence of dry acetone. So we all know that Finkelstein reaction is when you have alkyl halide, specifically chloride or bromide, and then you react it with sodium iodide in the presence of dry acetone so that we can get alkyl iodide along with NaX. NaCl or NaBr will be the byproduct. Now, why dry acetone is important here? Because the byproduct NaCl or NaBr that will be formed gets precipitated in dry acetone. If it gets precipitated, then the reaction will not go back. According to Le Chatelier principle, if we keep on removing one of the products, then it pushes the reaction in the forward direction. So that's the reason that we carry out this particular reaction in the presence of dry acetone. Next is the electrophilic substitution reactions with HI. They require the presence of an oxidizing agent like HNO3 or HiO4. and fluorocompounds cannot be prepared by this method, so we need to explain the reason. Now this electrophilic substitution reaction here is with respect to the haloarenes preparation that we are talking about. So the preparation is starting from phenol. When we are adding iodine here, it will be producing iodo plus HI. So the question is about this HI. The electrophilic substitution reactions where HI is formed, they require the presence of an oxidizing agent like HNO3 or HiO4. The reason is that this reaction produces HI, which is a very, very strong reducing agent. And this will try to go back to iodine. It will try to oxidize itself because it's a very good reducing agent. So we should already have oxidizing agents like HNO3 or HiO4 so that they can react with that HI formed during iodination and oxidize it, and reaction does not go back, because here the reaction with iodine is reversible. That's why an oxidizing agent required which can react with this and remove it. Now, fluorocompounds are also not prepared by this method. Generally, you will see the reactions are of chloro and bromo. They are easy. Iodo, I just discussed with respect to this particular question. Fluorocompounds, they are not prepared by this method because of the very high reactivity of fluorine, and sometimes the reaction is uncontrollable. That's why we do not generally see the reactions of fluorocompounds. Next question is why the preparation of diazonium halides, that is benzene diazonium halide, is carried out at 0 to 5 degrees Celsius, that is 273 to 278 Kelvin, because this particular compound is stable under ice cold conditions only. If the temperature reaches above 278 Kelvin, it dissociates, it decomposes to release nitrogen. So if I want to keep it stable, then this is the temperature range. Next question is why is sulfuric acid not used during the reactions of alcohols with Ki? Now, in this particular reaction, when alcohols react with Ki, the products are, what do we want to make? We are expecting that Ri will be formed. And here if I take sulfuric acid to carry out the reaction, then this Ki will give Hi on reaction with sulfuric acid. H plus will come from there. And I want to prepare Ri specifically. So H2SO4 being a strong oxidizing agent here, it oxidizes this Hi. Ki will convert to Hi and Hi will convert to iodine, I2, as discussed in the previous question also. So it does not react with alcohol. What we wanted that this will be formed, this should be formed, but the reaction goes in the other direction. H plus comes from the acid, Ki gives Hi, and Hi produces iodine. So the desired product does not get formed. That's the reason. Next is explain why the dipole moment of chlorobenzene is lower than that of cyclohexane. It should be cyclohexyl chloride. Cyclohexyl chloride or cyclohexane chloride. So here, if you have chlorobenzene and you compare it with this, the very clear difference is in the nature of CCl bond. Due to resonance here, you will be having a double bond character. But here, the double bond character is not possible. So because of that, what happens? The bond length decreases in this case. How will you express your answer? This is a long answer as expressed here, as given in NCRT. But you should know, according to the marks allotted, that exactly how much is to be written. So if they are just asking this for 1 mark, you can talk about this bond length, and hence the dipole moment is lesser in case of chlorobenzene. If it is for more marks, or if you exactly know how to write more in less words, then go for the reason like sp2 hybridization of carbon in this case here, and in this case it is sp3 hybridized. So more s character in case of sp2 hybridized one. So that is why it becomes more electronegative here, this carbon. So the CCl bond, the carbon electron density is basically more concentrated at the carbon. Again the bond length decreases, and that way also you can give your answer. So this is the complete information, all the reasons which are responsible for this. Reading it thoroughly will help you to frame your answer according to the marks allotted. So that was first presentation which I specifically made for this chapter's reasoning questions. Very soon I'll be uploading second presentation also, where I have discussed most of the remaining reasoning questions from the same chapter. I hope this will help you. Thank you so much.